everyone. So here is video number 2. And your example 2 is going to help you answer some of my math lab questions. And example 1 is going to help you answer question number 1 on this OL. Okay, so just take some notes and then you should be all set for the rest of this OL and you should be set for your My Math Lab. So you need your calculator and we're going to learn how to enter in data values in your calculator. And we will come back and talk about interpolation and extrapolation in a minute. So you're going to pull out your calculator. And the button I want you to hit to enter data into your calculator is this stat key. Do you see that? This is stat. My pen is pointing at it. So I want you to hit your stat key and then just hit enter. And then we're going to enter data values into these lists. So do you see how I have stuff in list 1 that I don't want in it? So I'm going to work my calculator all the way up so that L1 is highlighted. And then you're going to hit clear. Don't hit delete. If you do hit delete, it's not a big deal. I can undelete it in class. But we're just, for now, we're going to hit clear. And then enter. And all of the data values, I'm going to make sure your L1 and L2 are clear of data. Okay, so let's read the problem. So it says, let P equal F of T be the percentage of Americans who always wear seatbelts T years since 1990. Okay, so this is our time adjustment right there. We're going to make a column of data to represent that time adjustment on our table. So T is the year since 1990, and we're looking at all these different year values and the percentage of Americans who wear seatbelts at these various years. So our input is going to be in time since 1990. So if I'm 1992, my T value is 2. If I'm 1996, 6 years have gone by since 1990. If I'm at the year 2000, we've got 10 years. 2004 would be 14 years. 2008 would be 18 years have gone by. And for 1990, if we're at 1990 and now we're at 2011, how many years have gone by for that? Looks like we're at 21 years. Okay, so the first thing we want to do is we want to make a scattergram or a scatter plot on our data. And what they're asking us to do is just graph these points on our calculator. So in order to do that, we need to put in L1, my time value. These are my inputs. And in L2, we're going to put the output, which are our percent values. So what you're going to do is you're going to just type in the number 2 and then hit enter. And you'll notice that the 2 goes in and then the cursor just scrolls down in L1. So then we're going to enter 6, enter, 10, enter, that key down in the lower right-hand corner, 14, enter, 18, enter, and 21, and then enter. And those are my data values that are the inputs for this table. Now to get the outputs, just arrow over, and then you should be right under L2. And then we're going to enter in these percentages into L2. So 70, enter, 75, enter, 79, enter, right? 83%, 87%, and 91%. Okay? So So use a graphing calculator to draw a scattergram of the data. So we're going to put the data in our calculator. And then let's look to see how we would label, like if I had to plot these by hand, what would we label the X and Y axes? Okay, and that's what they're asking on the next page. So if we had to draw these by hand, the input is the left or right. Now that's not year values, but those are years since 1990. So it's labeled T, where T is years since 1990. So if we found T equals 2 on this graph, we would know that would correspond to the year 1992. And then on the vertical, on that up and down, if you flip back, that was the percentage of Americans who wear seatbelts. So this is the percentage of Americans who wear seatbelts. And they call this P or F of T. It's the same thing. So every ordered pair is going to be a T, comma, P value, where T is time in years since 1990, and P is a percent. Of Americans wearing seatbelts for that year. So when they ask to interpret an ordered pair, you have to tell what the input and the output mean, right? So there's two parts to every interpretation. All right, so let's turn on our calculator and make a scattered plot. So on my calculator, first of all, let's make sure there's nothing in y equals. So when I hit y equals, I've got a couple functions in there. So I just want to clear those out. I'm going to hit clear and then arrow down and clear again. So now my y1 and y2 are nice and clear. And then do you see up above it says stat plot? Do you see that? So what we're going to do, since it's in blue, I'm going to hit my blue key, the second key first, and we're going to turn a plot on. So yours probably all say off right now. We're going to hit enter and then enter again. To make a scattered plot, you want to make sure the first option is dark, right? We're not going to make a histogram or a box and whisker display. We're going to have the calculator plot some points. So just, if it's not, I mean, you can arrow down and hit enter, but just make sure that this is dark, and if it's not, hit enter now so that this one is blinking. And then just make sure your X list say L1 and your Y list say L2. If they don't, let's just pretend that said L3. So arrow down, and then do you see above the number 1, it says L1 in blue, and above the number 2, it says L2, and above the number 3, it says a blue L3. So if you want the X list to say L1 and it doesn't, all you need to do is hit second L1, or a second 1, and then the L1 will pop up. Okay, so if your setting looks like this, where your plot is on, your scattered plot is chosen, and you've got L1 and L2, to plot your points, you need to go to a special window. So we're going to hit zoom. And then, hold on, mine is not working. I'm going to hit zoom. There it goes. And now I have a cat that's going to appear on your screen. Okay, this is Leo. Okay, I'm so sorry. Oh, I'm not making this video again. So, all right. So when you hit zoom, hopefully it looked like this. So here, let me go back up. I had a cat distraction. So I'm at y equals, right? This is what your calculator looked like. I hit zoom. And then we're going to go down. You want to find zoom. I want to show you what it looks like. It's zoom stat. It's zoom 9. I mean, you can just hit the number 9 now, but it's zoom 9. And that will make a window so that all of your points are plotted. So we can look at it. If I just trace, so there's my first point, 270. You don't have to hit trace, but I'm just going to show you what these points are. There's our next point. 6 years past 1990, 75% of Americans wore their seatbelts. So you can check your point values by hitting trace and then the up and down arrow. So you can jump through those points. Are we good? All right, so that was the first thing. The second thing, it says, determine the linear regression equation. So what that is, a linear regression equation, is the best fit line that can be drawn that will be the closest to all of these points. That's what's called a regression equation. A lot of textbooks call it the model that best fits your calculator. Okay? So to tell the calculator, hey, I would like a line that hits closest to those points, we're going to hit the stat. And so when you hit the stat key, what we're going to do is say, okay, calculator, if we hit enter, that's when the list comes up. I'm going to hit stat and then arrow over to calc. And you see option number 4 says linear regression. I'm going to go down and hit option number 4. Okay, so it's make a line. Now make sure your X list is L1, your Y list is L2, and if it doesn't, you can arrow up and down and use the second one, second 2 to enter in L1 and L2. Now, our frequency is 1, so you can just leave that alone. We're not doing frequency lists, so just cross over that. Now, you can have the calculator store this equation. If your calculator looks like this, it can store the equation into whatever y variable you want it. So let's just have it do that. Do you see it says vars? So say, okay, calculator, I want you to store it in y1. So I'm going to hit vars, and then you see the y variables. So hit 2 enters now, enter, and then enter. And now the line that it makes is going to automatically dump it down into y1. And let's calculate it. Voila, there's our line. So let's, I think on my math lab they have you round it to 2, so let's just round it to 2. So we've got 1.07. Now look at that. A value is the number in front of x. So A is our slope technically. And ours isn't really x, it's t. Right? Our x values are t's. And then plus b. If we round this to 2 values, I don't know if it's 2 values or 3 values. I'm almost thinking it might be 3 values. Here, I'm going to put one more value in there. I'm going to put a 3 in there. I think it's 3 decimals. So 1.073 t. And then let's round this to 3. 68.138. We're used to mx plus b, but they just call it ax plus b. Okay, so the a and the m are the same. Now, if you want to look at your line, remember, we told it to put it into y1. So when I hit y1, there's my line, right? There's my m, if you could scroll over, x plus b. So now you just have to hit graph, and there's our line. Look at how nice that is. It's really close to all of our points. It's not exact, right? It's just an approximation. It's what's called the best fit line. But this comes pretty close to all of those points that we plotted. So it's a pretty decent looking line. And now we can answer questions. All right. So the p-intercept is the same thing as f of t. Okay. So if we have a p, remember it's t comma p. If we have a p value, then my input would be 0, right? Okay. Well, what happens if t is 0? What is my p-value? Looks like it would be 68.138. Right? If I have a p-intercept, I have a p, so the t is 0. So if t is 0, we've got 68.138. And it says, what does this mean in this situation? All right. So if we are 0 years since 1990, so in the year 1990, about 68.138% of Americans wear seatbelts. Okay. What is the slope? Okay, remember the slope is the number in front of your t-value. So the slope, the m, is 1.073. And you remember, I always sneak it over 1 because that's going to help us interpret it. So it's rise over 1, change in the output over the change in the input. The output is the percent, right? And the units on the input are years. So it looks like the number of Americans wearing seatbelts is increasing every year since 1970. So every year, I think it's 1990 though, every year since 1990, the percent of Americans wearing seatbelts is increasing by 1.073% per year. It's increasing because it's positive, and we knew it was increasing because the line is rising, right? More Americans are wearing seatbelts. Okay. All right, so now we're going to learn how to use our table key. Okay, it says predict the percentage of Americans who wore their seatbelts in the year 2007. Okay, so what would my t value be? Well, it's the number of years since 1990. So it looks like I've got a t value of 17. Now, I'm going to show you how to do this on our calculator. Now, my formula is in my y equals. So you have a key on your calculator that's called your table key. And this table key it's in blue. It's above graph. So I hit my second graph, and there's my table. This will evaluate points for you. Now, I'm going to delete all these. Hopefully yours is clear. Now, I want to make sure your calculator is in the right table set. So do you see above window, it's in blue, it says table set? So hit the blue key and then the window so that to make sure your table set. So the independent variable is the input. So I want the calculator to ask me the input and automatically give me the output or the dependent variable. So just use your arrows to highlight and then hit enter so that those, use my arrow down, I highlight it and hit enter, so now it's in the correct format. So now when I go to table, I could say, okay, if T is 17 and hit enter, it's going to tell me the percent. Okay, so let's see. Predict the percentage of Americans who wore seatbelts. So it looks like 86.376% of Americans wore seatbelts. In 2007. All right, so first of all, let's put this in function notation. So f of t, f of my input equals my output. So that's what it looks like in function notation. And they said, is this interpolation or extrapolation? So if you stay within the bounds of your data, you're interpolating. So if I use any years between 1992 and 2011, I'm interpolating. I'm staying in the bounds of my data. So 2007 would be on my table, so I'm staying within the bounds of my data. It's called interpolation. If you interpolate, you generally get some decent values from your model. When you extrapolate, that's when you get some of this model breakdown, like in this problem. This says, when will 100% of Americans wear a seatbelt? So we're looking for a t value. So let me write out my formula again. So f of t, or p, equals 1.073 plus 68.138. And we want to find t so that f of t is 100. Now we did this on the previous video. If you have both sides of the equation, you can put one side into y1, which it already is, the other side into y2, and then use your intersect key. Okay, so when I come over here, remember y1, I already have my equation. So I'm going to arrow down and I'm going to put 100 in for y2. Now when you hit graph, you might not see anything. Do you see I don't see the 100? That should be this nice horizontal line. So let's look at my window. Oh, look, my window only goes up to 94, and I just told the calculator I want it to go up to 100. So let's go down and make our y max, I don't know, let's make it 200. So then we'll definitely see the 100 in there. So when I hit graph now, there's my points, and there's my 100. Now do you see? You can't see where they cross. They cross maybe out here where my pen is. So now we need to make our x value bigger. So I'm going to go to window, and I don't know how big we need to make it. Maybe let's make it 60. Let's see if that's big enough. So there's my percentage of Americans who are wearing seatbelt. This is when 100%, this is the year that says, oh, this is the year where 100% of Americans are going to wear seatbelts. To find out where they cross, remember, if in doubt, go to calc. It's right above traces in blue. Hit number 5, and then 3 enters. 1, 2, 3. So according to the model, 29.698 years, and my math lab always says go to the nearest year, so it's going to round up to 30 years beyond 1990. 100% of Americans are going to wear seatbelts. So 30 years beyond 1990, 100% of Americans will wear seatbelts according to this model. Okay, let's see. What year is that? 1990 plus 30. So in the year 2020, according to this model, everyone wore seatbelts 2 years ago. That's the year. So hopefully you are thinking, this might be a good example of model breakdown. And it is because we're outside the bounds of our data. And when we go way out, that's what's called extrapolation. We extrapolate when we're outside of our data. So do you see 2020 is way outside of the data? So sometimes when we extrapolate, that's when model breakdown occurs. So we got an answer, but it really doesn't make a whole lot of sense because I'm thinking not everyone wore their seatbelt 2 years ago. So this is an example of extrapolation. It's model breakdown, but let's put it in function notation. It would be f of 30 equals 100. And then the last one, t-intercept. So t-intercept means you have a t, but the output is 0. Okay. So the output is 0. So you're just going to repeat the intersect function again. This is my input. This is my output. Y1, Y2, we'll put 0 in. Okay, so let's see what we got. So I'm going to come down here and put 0 in. I'm going to hit graph. And I don't see anything drawn down here, right? Now look, if we go to my window, that's because it doesn't go to 0. Do you see that? It only goes to 0.1. So maybe let's make this -4, so then I'll be able to see where these cross. So here's my line. Now if you're like, what, Kathleen, I still didn't see this being drawn in. You don't have to do this. I'm going to show you something though. If you want to see it drawn in a little darker, you can change the form. Like I'm arrowing down and to the right. Do you see that? It's blinking now on my calculator. If you want it to be like a little darker, just hit enter on it, and then you'll see when you hit graph, there's my line, and then you should see the other one being drawn in. Did I draw my, -4. Oh, here, wait. I'm sorry, we've got to make our y min small too. So let's make our y min -4 because y was 0. So we have to make our y min -4. Okay, ready? Give you a chance to make that -4. So now we have small x, small y. Now let's see if we can see it. Okay, there's that. Do you see it being drawn in there? Can you see it now? Now look, the t-intercept, that's not going to be until way over here. Do you see my pen? Where this thick line and this line cross, it's got to be way over here. So that means I need to make my x value even smaller. I've got to make it super small. So I don't know, let's try, we're at -4 for x, maybe -100, and let's see if these are going to cross. Oh, yep. Do you see it being drawn in? So right there is where they cross. Do you see that? So if in doubt, go to Calc, option 5, and then 3 enters. 1, 2, 3. Oh my goodness. So there it is. So the ordered pair, when, I'll write the ordered pair down, is going to be -63.51. Look at that again, comma 0. hopefully that's what you got. Okay, so this is the years since 1990. And this is going to be the percent of Americans who wore seatbelts. So they're really going extreme. This is hugely extrapolation, right? We are way outside the boundary. So what does this mean? 1990 minus 63.51. So this was back in the year 1926. Nobody wore a seatbelt, according to the model. I don't know about Model T cars. They maybe didn't have seatbelts, but I still think since we're extrapolating, this would be considered model breakdown. All right, so hopefully now you can do the question on the next page, and then I'm going to do this because this is in my math lab. So, but we're going to use our calculator. So let's read the question. So if you need a break, stop the video now and then come back. But I'm just going to push through and answer this question, and then you should be set to do the My Math Lab, which will be open, and the rest of this. Oh, wow. All right, so go ahead and read the question, and we're going to find two ordered pairs. Okay, now there's no time adjustment for this. Do you see that? So I'm just going to pick two values. The input's always time. So in 2011, there was remember time's always the input, 3.2 thousand spent, nope, I think I read that wrong. 2011, 10.7 thousand was spent. Right, 10.7 thousand is going to be a 7. And then in 1985, 3.2 thousand was spent. Now, if we had to do this by hand, we'd find the slope, and then from the slope, we would find the b-intercept. But now we're going to use our calculator. So let's practice entering in data again. So I want to enter these two pieces of data into my calculator. So I'm going to hit Stat, Edit, and then we're going to clear these lists. And then I'm going to enter these two values. Now, I'm going to enter the years only because they didn't have a time adjustment for this problem. So just read it carefully. If they have a time adjustment on my math lab, then you would do a T column. All right, did you see what I did? I entered in my inputs for time, and then I just arrowed over, and I entered the Y values. And to clear the lists, here I'm going to clear this list. You work your way up till the list is dark, hit clear, and then enter. And that's how you clear a list out. Okay? Now let's just go through it again. I'm going to clear my Y equals out because we're going to enter in new stuff. So I cleared that out. And then let's go back up and just practice plotting the line connecting these 2 points. So my plots are on. To have the calculator make the graph paper, you just hit zoom and then 9. And there's my 2 points. And now we're going to tell the calculator to make a line. So I'm going to hit Stat, Calculate, and then option 4. L1 and L2 are good. And I'm going to tell it now to store it in Y1. So you go vars, Y vars, and then 2 enters. And when you calculate it, it's going to pop it right into your Y1. So you don't have to retype it in. I'm going to write it down. So y equals the slope, 0.288. I'll put t because t is time in years, minus 569.396. Okay. So now they want to know the expenditures in 2024. There was no time adjustment for this one, so I'm just going to put 2024 in for T. But you can use your table key, right? So if we go to table and type in the input 2024, there's the expenditures. Right? So we're going to get comfy using our calculator to help us calculate these out. So in 2024, the expenditures per student expenditures was $14.45 thousand. So now you can answer the questions on My Math Lab using your calculator. Now, if they said on My Math Lab where T is the years since 1985, then of course you would put 0 here and you would adjust it for there, right? Because that'll make that B value a little different. So just read the My Math Lab very carefully and let me know if you have any questions. You should be able to answer this question now on chicken consumption pretty easily. And then you should be able to go into 5.6 and answer those My Math Lab questions as well. All right, thanks for sticking it out. Let me know if you have questions. This isn't due until Wednesday, so you can ask me on Monday, and I hope you guys had a real good weekend. All right, we will talk to you soon.